So here we're going to finish up with the lower scoring categories. The last one we need to do is small straight. So we're looking here in the game model, and I'm looking to see which one would be most appropriate to copy from for is small straight. You'd think it would be is large straight, but really what we need is something a little bit fancier, kind of like full house. So again, we're just going to borrow the insides of this and create another method here, kind of modeled after it. And we'll give it a method header and say public boolean is small straight, and we'll take the dice as a parameter. We do want to build a frequency table, so we're going to delete these booleans, but we do need the frequency table, so we do build that. Okay, next we want to loop through the frequency table, and what we're trying to do is remove any duplicates. So we have the loop already set up, and we're iterating through the loop. And what we want to look for is anything that's not a 1. Or actually anything, that's higher than 1 would be a better way to say it. So if frequency table sub I is greater than 1, then we want to actually replace it with just a 1. So we use the same code here, and all we're doing is replacing any value in the frequency table that has more than 1. We're going to set it equal to 1, and then that'll make it a little bit easier for us to do our patterns. So when we're done with this little operation, we'll have 1s in all the slots where there's actually a die. If it didn't have a die that had that value, it would have a 0. But if you had a slot in the frequency table that had more than 1, now it's actually set to 1. Alright. Next we have to ask a few more questions. I suppose the first thing to check would be whether you have a 3 and a 4. Every small straight that you could possibly have in Yahtzee has to have a 3 or a 4. So we're going to use the process of elimination to make our determination a little bit better. We could say that if 3 and 4 are not, if they don't have 1s in it, then we know that it's not a small straight. Alright, up here at the top, we're going to add a return value to our is small straight method. We would say boolean, I just call it return value. For lack of a better name, and we'll set that equal to true. We'll assume that it's true at the start, and then we'll just change it later if we find that's not the case. So we've looped through our frequency table, we've set all the slots that have something in it to 1, and now we want to start testing if we actually have a small straight. First thing to check would be 3 and 4. We need to, every version of a small straight has a 3 and a 4 in it. You either have 1, 2, 3, 4, or 2, 3, 4, 5, or 3, 4, 5, 6. So we might as well get that taken care of first. And if we don't find a 1 and 3 and a 1 and 4, then we know that it's not a small straight. So we'll add that now. If there's a frequency table sub 3 is equal to 1, and I can fix my typos, and frequency table sub 4 is equal to 1, then we know we have a possibility of it actually being a small straight. But there's other things we have to check. Now in the case where it's not that way, we know then that there's no way for it to be a small straight, so we're going to just say return value, or we're going to set the return value equal to false, because we found out, it's not a small straight. So here we're going to do a set of chained else ifs for this next section. The way the pattern goes is you say if frequency table sub 1 is equal to 1, and frequency table sub 2 is equal to 1. If that's true, then we know it's we know that it's true and should remain true. Okay, so I'm looking here at my code and I'm trying to decide what we should do here with the return value, and I'm struggling. I'm thinking the best approach would be just leaving it uninitialized, and then we have to make sure that as we go down here that every path through this logic sets the return value to a specific value. Here we know that if we don't have a 3 and a 4, then the return value is going to be false. And so here at the end, the last thing we do is we just return the return value. So like that. But now we have to be careful. Since we're not pre-initializing the return value or making any assumptions, we need to be a little bit more careful as we're going down here. So we know that if we have a 3 and a 4, that there's a possibility that it could be a small straight. Now if we have these two things, if we have a 1 and a 2, then we know for sure that we have a small straight. So we would set the return value equal to true, because we're certain we know what that is. But we have some other things to test. It could be 2 and 5, or it could be 5 and 6. So we're going to add those tests here. We'll say else if, and this time, let's borrow these. We're going to check for 2 and 5. Remember, we've already eliminated 3 and 4. Okay, so there's 2 and 5. If that's the case, then we can set return value equal to true. And then finally, again, we'll borrow some of this logic. Looking for 5 and 6. So here we see 5 and 6. Now, if it's none of those, say you've got all the way through this else if chain, and you haven't figured out, or you haven't seen any of these patterns, then you know then that this isn't a small straight. So you don't have to say else if, you can just say else. Again, don't ask questions you already know the answer to. So we set the return value equal to false. This is an important one. If you forget to do this, then the compiler should complain that the return value hasn't been, or there are paths through this that haven't been initialized. Let's just try that and see what the compiler says. Notice here at the bottom, you get a red line and it says variable return value might not have been initialized. So it knows that, hey, you know, this isn't quite right. You didn't cover all the bases. As soon as we comment that out, then the compiler goes, oh yeah, that's fine. That'll work great. So here it is small straight. Kind of complicated. But you know, if you take some time to study the logic here, I think you'll find that this is a pretty efficient way of determining whether or not it's a small straight. But again, this is only half the battle. We've determined that it's a small straight or not, but we also have to put the test for it over here in the frame. If you look up here, there's the event handler for the small straight button. This time we're going to borrow from large straight, and we'll paste that in here for small straight with a few minor changes. Alright, score 0. This time we say small straight, so we'll do that now. Go into the scoring state, call our newly created is small straight function. And the score for small straight I think is 30, so we'll use 30 as our, and again, we're just replacing some of the constants. And then the rest is the same. Alright, so now it's time to try this out. My hope is that we now can play a complete game of Yahtzee. We'll see if there's any bugs here. Haven't done really any extensive testing yet, so all bets are off when it comes to whether or not this actually works 100%. Okay, so we're looking for a small straight. So I'll play until I see one. Here we have a 4 and a 5. Those would be good ones. There's a 2 and a 3. So 2, 3, 4, 5. Hopefully when we click on this we're going to see 30. And we did. The other one we want to try is when it's not a small straight. Here's a case when it's not. That's correct. New game again. Further testing, you might try each of the different ones, see if you can create them. 1, 2, 3, 4. To make sure that one works. There's 2. Nope. But yeah, test all the other ones. You want to also test it when you have a doubled up one, like say you have 1, 2, 2, 3, 4, or 1, 2, 3, and another 3 and a 4. Yeah, you want to test those out too to make sure that our algorithm is actually processing those correctly. But I'm going to test this for a while, and if I find any bugs, I'll pop back into this video and talk about how to fix some of them.